At this very second, something is happening to your body. If you've been sitting for more than an hour, your cells are making a decision that will echo for the next 10 years, and you can't feel it at all. Your mitochondria are dimming, your hip flexors are shortening, your blood vessels are closing down routes, your skeleton is beginning to remodel. After age 40, these decisions happened 3 times faster than they did in your 30s. By the end of this video, you'll understand exactly what 10 years of sitting rewrites in your body, and why the process is completely invisible until it's already done. Here's the pattern that makes this worth investigating. Take 2 people, both 40 years old, same health, same genetics, same starting point. One spends their day moving, teaching, nursing, walking around an office. The other sits at a desk for most of the day. At 50, something striking appears. They're the same calendar age, they've lived the same number of years, but when researchers measure their bodies, they find something odd. Their biology looks like it belongs to people born a decade apart. Different muscle composition, different cardiovascular measurements, different brain structure, different cellular markers. Same years lived, different biological aging. This video tracks what happens inside your body during those 10 years of sitting after 40, why it triggers cascades your younger body could handle, and why you don't notice any of it until year 7 or 8. Let's start with what happens in the first 90 seconds you sit down. When you sit down, your body makes a series of instant adjustments. Within 90 seconds, the electrical activity in your leg muscles drops by about 70%. Not completely off, just much quieter. Picture your muscles like cities at night. When you're standing and walking, they're bustling, lights on everywhere, energy flowing, activity humming. When you sit, the cities go into power-saving mode. Streetlights dim, office buildings go dark, traffic slows to a trickle. After about 20 minutes, your metabolism follows the same pattern. It slows by roughly 20 to 25%. Your body shifts from actively burning fuel to conserving what we have. Here's where age becomes the turning point. In younger bodies, this reverses quickly when you stand up. The muscle activity surges back fast, metabolism rebounds. The city lights flash back on almost instantly. But after 40, something changes in the power grid itself. The lights take longer to turn back on. The city takes longer to wake up. The rebound is slower, less complete. 1 hour of sitting triggers these small changes, nothing alarming, nothing you'd feel, but your body is collecting data. And when you sit for several hours, when this becomes your daily pattern, your body stops treating it as temporary. It starts adapting to sitting as if this is the new permanent reality. Think of your body as a hotel with cleaning crews that work overnight. Every night while you sleep, these crews move through your entire system, repairing damage, replacing worn-out parts, clearing waste, resetting everything for the next day. In your 20s and 30s, they're incredibly efficient. You wake up almost completely restored to baseline. After 40, the cleaning crews start working slower. Not dramatically, not all at once, but measurably. Now add what happens when you sit for 8 hours. By hour 4, your blood flow has slowed in your legs, like rush hour traffic that never quite clears. By hour 6, your hip flexors have been in a shortened position for hours. The muscle fibers aren't just tight, they're beginning to physically adapt to this length. By hour 8, your spine has been compressed under your body weight all day. The discs between your vertebrae are like sponges being gently squeezed. In your 30s, the overnight cleaning crew handles all of this. You wake up tomorrow mostly back to baseline. In your 40s, they reset about 85% of it. That other 15%? It stays. Tomorrow, you sit again. Another 15% residue accumulates. The day after, the same. Over weeks, this residue builds. Over months, it becomes measurable. Over years, it becomes structural. The hotel is still running, but it's not the same hotel it was 3 years ago.
And the first major system to fundamentally transform is the one that powers everything else in your body.
Inside every cell in your body are tiny structures called mitochondria. Think of them as power plants. They convert the food you eat into energy your cells can actually use to function. And they're surprisingly sensitive to the signals they receive from movement. When you move regularly, walking, standing, even just shifting around, your muscles send constant signals to these power plants. We need energy. Stay active. Keep the turbines running. When you sit for extended periods, those signals decrease. And when the signals decrease consistently over time, your body makes a logical calculation. We're running a city that doesn't need this much electricity anymore. Let's start closing down power plants we're not using. In younger bodies, movement seems to reverse this fairly quickly. The power plants stay responsive. But studies tracking people over 40 suggest something different. Over several years of prolonged sitting, the total number of functioning mitochondria in muscle tissue may decline by 20 to 40%. One power plant closes here, another shuts down there. The decline is steady but invisible. You don't notice this day to day, but over years it shows up as feeling more tired doing the same activities, needing longer to recover from exercise, having less energy later in the day, that afternoon slump hitting harder. But here's what's actually happening. This isn't inevitable aging. It's your body adapting to the environment you're giving it. Less movement signals fewer power plants running. And this energy slowdown enables the next change, one that's even more surprising. Your skeleton is alive. It's not a fixed structure. It's constantly remodeling itself based on the forces you apply to it. There's even a principle for this. Bones strengthen where you use them and weaken where you don't. When you sit for most of the day, year after year, your skeleton slowly adapts to optimize for that position. Studies tracking spinal changes over decades show a pattern. The lower back curve tends to flatten. The upper back curve tends to increase. The neck shifts forward. These aren't postural habits you can fix by sitting up straight. They appear to be structural adaptations. Your vertebrae may actually remodel slightly to accommodate the sitting position. Similarly, research indicates that hip flexors, muscles that stay shortened for hours daily, may permanently shorten. The hip capsule might tighten. Your pelvis may tilt forward. After a decade, some people find they can't fully extend their hips anymore. Standing up straight requires effort. Walking, naturally, becomes harder. But here's what's fascinating. Your body isn't broken. It's being incredibly efficient. It's reshaping itself to be better at sitting, because from your body's perspective, sitting is what you're asking it to optimize for. Now, skeletal changes are interesting, but what happens to your cardiovascular system is more concerning. Your cardiovascular system, heart, blood vessels, entire circulatory network, evolved for movement. Research suggests that prolonged sitting after 40 affects this system in stages. Your heart, like any muscle that isn't challenged, may become less efficient. Studies suggest stroke volume, the amount of blood pumped per beat, decreases slightly in sedentary individuals. Your blood vessels seem to lose elasticity. Think of rubber bands that have been sitting unused for years. They become stiffer, less springy. And here's what's particularly interesting. Some of your smallest blood vessels, capillaries, may actually close down. Your body maintains capillaries based on demand. If muscles aren't regularly demanding oxygen and nutrients, the body may reduce the capillary network. Studies have found that people who sit 8+ hours daily for a decade tend to have 15 to 25% less capillary density in leg muscles, slightly elevated blood pressure, and higher resting heart rate. These changes happen quietly. No symptoms, no warning signs. But there's one system that responds to sitting in a way that genuinely surprises most people, and it's the one you'd least expect. What does sitting have to do with your brain? More than you might think. Your brain uses about 20% of your body's oxygen, despite being only 2% of your body weight, and it gets that oxygen from blood flow.
Research tracking brain changes over time has found something striking. People who sit for extended periods after 40 tend to show slightly reduced blood flow to the brain, 10 to 15% less than active individuals, and measurable changes in certain brain regions, particularly the hippocampus, which is involved in memory and spatial navigation. A 2022 study found that adults over 40 who reported sitting 10+ hours daily had brain scans that looked, on average, about 10 years older than adults of the same age who sat less than 4 hours daily. But here's what's fascinating. Your brain appears to adapt based on stimulus. Movement sends constant signals, balance challenges, coordination demands, spatial awareness updates. Sitting sends fewer signals, and over years, research suggests the brain may respond by optimizing for that environment. What this feels like, forgetting names more often, losing track of where you put things, feeling mentally foggy, especially afternoons. Most people assume this is just normal aging, but research suggests it may be more about adaptation to environment than inevitable decline. Now we need to ask, what's happening at the cellular level that enables all these changes? Every cell in your body has a kind of biological clock, partly determined by structures called telomeres, protective caps on the ends of your chromosomes.
Each time a cell divides, telomeres get slightly shorter. When they become too short, the cell can't divide anymore. Short telomeres are associated with aging. Long telomeres are associated with youth. A 2017 study measured telomere length in adults over 40 and tracked their sitting behavior. Active adults, telomeres shortened at about 1% per year. Adults sitting 8 to 10 hours daily, telomeres appeared to shorten at about 2% per year. Over 10 years, the active group, about 10% telomere shortening. The sedentary group, about 20%. The sedentary group's cells looked about 10 years older biologically, despite being the same calendar age. But here's what's intriguing. Studies show that when people increase their movement after years of sitting, their rate of telomere shortening appears to slow, though they don't regain what was already lost. Your cells are adapting to match your activity level. And this cellular aging appears connected to the most visible change of all. Muscle loss is normal with age. After 30, most people lose about 3 to 5% of muscle mass per decade if they don't actively work to maintain it. But sitting appears to accelerate this significantly. Studies tracking muscle mass in sedentary versus active adults over 40 suggest sedentary adults may lose muscle at roughly twice the normal rate, about 6 to 10% instead of 3 to 5%. By year 7, sedentary adults might have 20 to 30% less muscle mass than they started with. By year 10, some studies suggest total muscle loss could reach 35 to 45%. But here's what's interesting. This isn't just about size. Research shows that remaining muscle in sedentary adults tends to accumulate more intramuscular fat. The muscle becomes marbled. What this looks like? Difficulty standing up from low chairs, struggling with objects you used to lift easily. Walking upstairs feels noticeably harder. But here's the fascinating part. Studies of people who began resistance training even after years of being sedentary show they can regain significant function, though typically not all the way back to their starting point. And muscle loss creates another problem: your metabolism.
Muscle is metabolically expensive. It burns calories even when you're not using it. When you lose 35 to 45% of your muscle mass over a decade, your baseline calorie burn, your resting metabolism, drops significantly. Studies suggest that for every pound of muscle lost, your daily calorie burn decreases by about 35 to 50 calories. Lose 20 pounds of muscle? That's 700 to 1,000 fewer calories burned per day just existing. This is why the same diet that maintained your weight at 35 leads to gradual weight gain at 45. Your body has adapted its metabolism to match the sedentary environment. Now let's see how all these pieces connect. Here's what makes this genuinely fascinating. These aren't 8 separate problems happening independently. They're one interconnected cascade where each change makes the next one more likely. Sitting reduces muscle activity, which decreases energy demand.
Less energy demand signals mitochondria to slow production. Fewer mitochondria means less cellular energy available. Less energy creates more fatigue. Fatigue reduces motivation to move. Less movement means bones adapt to the sitting position. Skeletal changes make movement less comfortable. Discomfort leads to more sitting. Prolonged sitting decreases blood flow. Reduced flow causes vessels to stiffen and brain to receive less oxygen. Less oxygen creates cognitive changes. All this cellular stress accelerates telomere shortening. Faster cellular aging makes all systems age faster. Muscle loss accelerates, metabolism slows further. It's not really 8 different problems, it's one adaptation triggering the next in a self-reinforcing loop. And here's what makes this cascade so hard to interrupt. For the first 5 to 6 years, you probably feel mostly fine, maybe a little more tired, maybe some stiffness. Then somewhere around year 7 or 8, several things seem to surface at once. But they're not sudden. They're the accumulated result of years of quiet adaptation finally becoming noticeable. Which raises the obvious question: why does this cascade happen so much more readily after 40?
What makes 40 the inflection point where sitting triggers these cascades more easily? The answer: your body's repair and maintenance systems change. In your 20s and 30s, you have robust systems, efficient cellular cleanup, strong tissue regeneration, effective stress response, good inflammatory control. These maintenance systems can handle the daily stress from sitting. They repair most of it each night. Around age 40, research suggests these systems begin working less efficiently. So the same amount of sitting that had minimal lasting impact at 30 now leaves residual change at 45. Before 40, daily stress from sitting is less than repair capacity equals mostly reset. After 40, daily stress from sitting exceeds repair capacity equals gradual accumulation. Over 10 years, that accumulated adaptation becomes substantial. The hotel cleaning crews are still working, they're just slower. And when they're slower, the mess builds up faster than they can clean it. Here's the psychological puzzle that makes this cascade particularly tricky to catch. The changes are invisible for years. You're sitting at your desk, you feel fine, you're productive, your back doesn't hurt. Meanwhile, your mitochondria are closing down, your bones are remodeling, your blood vessels are shutting routes, your brain is receiving less oxygen, your telomeres are shortening faster. But you can't feel any of it. Then, around year 6 or 7, you start noticing things. You're more tired, your back feels stiff, stairs seem harder, you're forgetting things more often. But you don't connect these changes to sitting. You think, I'm just getting older, this is normal aging. And because you believe it's inevitable, you don't consider changing your environment. By the time that changes become obvious, around year 8 or 9, much of the structural adaptation has already happened. This is what researchers call a lag effect. The behavior happens for years before the consequences become apparent. Like compound interest in reverse. Small daily choices compound into substantial changes over time.
Here's the most important reframe. Your body isn't being destroyed by sitting. It's adapting to sitting. Your body is constantly trying to be as efficient as possible for the life you're actually living. You sit all day? Your body says, understood, let's optimize for that. Let's reduce the expensive energy systems we're not using. Let's reshape the skeleton to be more comfortable in this position. It's remarkably intelligent adaptation. The problem is, it's adapting to an environment that doesn't match what you need for long-term health and function. But here's what's genuinely encouraging. Because it's adaptive, not inevitable decay, it responds when you change the environment. Studies show that people who increase their movement after years of being sedentary tend to see some improvement in mitochondrial function, better cardiovascular markers, slower rate of muscle loss, reduced rate of brain volume decline. Not a complete reversal to where they were at 40,
but meaningful improvement. Your body is constantly reading the signals you give it and adapting accordingly. Change the signals, and the adaptation changes. The biology isn't fixed, it's responsive. This video explored one question. What does a decade of sitting do to your body after 40?
Your body after 40 is constantly adapting to your environment, not just sitting, everything. Sleep patterns, stress levels, social connection, mental challenges. Each of these triggers biological cascades. Some you notice, most you don't. That's what this channel explores, the hidden adaptations happening in your body between 30 and 60. The biological cascades that respond to how you live. The changes happening silently right now that are reshaping your future self. Because aging isn't a straight line, it's a series of adaptations. And understanding what your body is adapting to changes how you think about what's happening to you. You're not just getting older, you're adapting. And now you know what to.